Hi, I'm James Walker, Senior Editor at Data Center Knowledge, coming to you live from the news desk at Data Center World 2025 in Washington, DC. I'm here with Manoj Sukumaran, Principal Analyst at Omdia's Data Center Compute and Networking practice. Manoj, thank you for joining us.
It's a pleasure joining you.
Thank you. We've got lots to talk about today. This week's Omdia Analyst Summit, which took place earlier this week, it really set the scene for not only Data Center World, but the entire industry. And your analysts mentioned that compute demand for AI is doubling every 5 months and that the global data center capex could hit $1 trillion by 2030, of which I think 400 billion would be in servers and compute. Do you think this pace is sustainable, or are we headed towards a resource crunch, whether this is in energy, land, or the supply chain?
Well, the way I see it is this is actually a new era of computing. Whatever the computing systems that we have built so far cannot really run these large language model workload in a very efficient manner. And it needs a whole new different perspective of looking at the way computing is done. And the new GPUs and the custom ASICs which is coming into the market are actually tailored to process these workload in a highly efficient manner. So that's actually a new infrastructure that we had to build for the AI era. So I look at it from from that perspective, we are at the beginning of this AI revolution. So the way I relate is in the telecom world, we had a 2G, 3G, 4G, 5G kind of evolution, right?
Yep.
So I believe that we are in the 2G era of AI.
Okay.
And there will be much more to come in the days forward. Maybe a lot of people talk about artificial general intelligence and an agentic world, etc. So maybe those could be the things which we'll see in the maybe 4G, 5G era, but 4G, 5G era of AI, but I think we are at the beginning of it. So there is a lot of infrastructure which needs to be built to do this computing in a very efficient manner. And that is exactly why we see this the strong investment which is going into this. Companies building large GPU clusters and AC clusters to train their models. And it's a very recent phenomenon, right? OpenAI launched ChatGPT in the late November 2022. It was just 2.5 years back.
Yep.
So from that moment, this industry gained momentum and realized that this needs a very specialized computing, and we started building infrastructure at a massive pace. And a lot of this build out that we were actually planning is just happening. We are yet to see the right now we have 100,000 and 200,000 GPU clusters, and we expect to see a million GPU or a million AC clusters actually going forward. So I think the investments are likely to happen in a much more aggressive manner going forward. And on the way, I think there are a lot of challenges. It's not really an easy way ahead. There are challenges of power, there are challenges of cooling infrastructure and data center land, buildings. Everything has to come up. But I think that big brains working under it with enough resources will find ways to do it. We say power is a big bottleneck.
Yep.
But yesterday, I was actually meeting a vendor on the expo floor who was actually building ship engines, and they're trying to use the ship engines to build power generation for data centers now.
Wow.
That's a very innovative way of solving the power problem. So I think we'll see a lot of innovation going forward, and all those innovations will actually drive the capital for data centers.
And just to develop on that point about power and how it pertains to hardware, you previously mentioned that I think 60% of energy in AI systems is used for just data movement. Are there any other architectural solutions besides tighter GPU integration that could shift that balance?
Yeah, we see. So if you look at all the GPU roadmaps of companies, we see more and more compute getting concentrated into a single system or even to a single package,
Okay.
chip package. So the NVIDIA Rubin Ultra, which is expected to hit the market in 2028, has got uh, 4 rectangle-sized dice in it, and it's like it's like a massive amount of compute in a single package. So and it is just the compute dice, and there is memory dice also along with it, providing massive amount of memory and compute. So why we have to do it is because, as I said earlier, right, um, there is a lot of data movement involved in AI computation, and all this data movement needs to be reduced. The energy for the data movement needs to be reduced, and one of the ways to reduce data movement is to have a tighter um, like density for the compute elements and also for memory. So we believe that there will be challenges as computing get more intensive and memory hungry. I think there will be more closer integration going forward because we are solving the packaging issues, the thermal and power issues, thermal management and power delivery issues in multiple ways. So I think we'll see more denser compute systems coming on our way as we move forward.
Okay. And what are your thoughts on the competitive landscape? I guess with so many new HPC chips announced this past year, I know you've been attending various analyst events, both sides of North America.
Yeah.
Some of these chipsets are supposedly 50 times better TCO and power efficiency. Do you see a clear winner emerging in this race, or will the diversity of architectures lead to a sort of fragmentation in AI infrastructure?
So the way to look at this is from a slightly holistic perspective rather than just looking at a chips capacity or a silicon's capability, right?
Okay.
So it is not just the chip; it's actually the system, and also the software which actually exploits these system capabilities. What kind of like efficiency improvements and what kind of like performance capabilities that software can actually exploit from the chip and use it to produce maybe in the AI realm. We talk about the tokens, right? How efficiently you can actually generate tokens, and how efficiently you can actually manage process tokens. This is all what it matters.
Okay.
So it is not just like the improvements in silicon, but also it takes a lot of innovation and a lot of optimizations at the system level and also at the software level.
Okay.
So if I look at it from that standpoint, there are not many companies who has actually solved all the problems that we see today. So it is when you are actually moving from a silicon to a system, there are interconnect issues, there are networking issues when you have to cluster multiple systems.
Yep.
And you have like power and thermal issues which needs to be managed, and then obviously you need optimized software which can actually exploit the hardware capabilities and deliver high efficiency computing.
Okay.
So there are not many companies out there who has actually solved it, and obviously Nvidia has a big advantage because they're working on this for so many years, and they've created developed a lot of technologies for this, and also optimized their software architecture out there. Um, there are some custom silicon like the TPUs and maybe the AMD's GPUs and all that who's actually like inching closer to it. But in the open ecosystem, where you and me can actually buy a chip and like build a system, it's like in NVIDIA and AMD right now, right?
Right.
Most of our others are actually custom silicon. So
Yeah.
there are not many players who has got the performance and efficiency at a system level, or I would say at a full stack level.
Okay. Right. You recently posted on LinkedIn, I guess to debunk the myth that GPUs aren't purpose-built for AI, pointing out that chips like the H100, B200, and MI13 are AI-optimized ASICs, not graphics processors. Could you walk us through this, like why this misconception persists, and what people often get wrong when comparing GPUs with TPUs?
So whenever we discuss AI, there are sort of people who thinks that Nvidia got accidentally benefited from this AI wave because they can actually repurpose their GPU technology for AI. So that's actually a big tailwind for them, and they could actually create a leadership in the market.
Yep.
But that's not actually true. Nvidia started to realize, obviously, the GPU, the graphics processing unit, they realized that the parallel processing capabilities of GPUs are advantageous when it comes to AI processing capabilities. That's why Jensen mentions always about the AlexNet, which used GPUs to fasten AI, both training and inference back in the day. But from that moment onwards, NVIDIA started realizing this is a big opportunity going forward, and they started coming up with silicon customized to these kind of computing. So on the way, they have not really solved just the computing problem, but also the system level problems that I talked about, right? The interconnect issues. They developed NVLink. They they bought Mellanox for networking and used and optimized their InfiniBand networking. They invested in CUDA software architecture, and so they have done a lot of things on the way. And if you buy a H100 or a Blackwell GPU right now, you can't really run a graphics workload on it.
Yeah.
It's actually purpose built for AI. And if you look at the data types and the processing elements, they're all optimized for AI workloads.
Okay.
So, and anybody who's actually building a custom ASIC, right, they'll be taking the same path. There'll be a compute element, either a systolic array or or some kind of a matrix multiplying unit, and then they'll actually pair it with a networking for the compute elements within the chip. There'll be some IOs, some SerDes interconnects, which actually interconnects these ASICs or GPUs. So it's all very similar.
Yeah.
So that's why I always say that the Blackwell B200 or B300 or the H100, you can call it a GPU, but if you look at it, it's like very much tailor made for AI workloads, and they're ASICs in that manner. And NVIDIA decided to use the nomenclature of GPUs for all their products, but anybody else could use they could call a GPU or an ASIC or an intelligent processor unit or whatever they want to call it.
Okay. Interesting. And then lastly, as a journalist and editor, I've been closely following how AI is reshaping the landscape. Software developers, those in the creative industries might already be feeling the impact. How do you see AI affecting the analyst's role? And do you have any concerns that advantages like so-called deep research tools could eventually displace parts of your job?
It's actually getting really interesting, especially the deep research capabilities, right? So one of the things that as analysts we used to do is consolidate a lot of information which is scattered around multiple places across multiple vendors and multiple technologies and all that, and used to provide a comprehensive picture of it. But I think that kind of a work definitely technologies like the deep research can solve. But obviously there is a lot of value that we as an analyst provides to end users. We have knowledge of technologies which is not published out there. Obviously, these tools works on the information which is available on the internet.
Sure.
And also maybe information that is specific to a particular vendor or a set of vendors and all that. But the job of industry analyst is actually to look at it from a much deeper, closer perspective, figure out what exactly is the difference, have a complete understanding and be able to differentiate one technology from another. And so there is actually an intellectual value that we bring as an analyst to the table, right? So that is something I believe and also there are a lot of information which is not there out there in the open which we get with human interactions that we build with the industry and the vendors and the ecosystem.
Yeah.
So I think those will be the biggest differentiators going forward. The intellectual capacity that you bring in, and also the information and the network, that the way you use your network to get additional information which is not there out there. So I think it's going to be much more challenging. It's not going to be an easy peasy world as maybe it was earlier, but I think it is actually becoming much more valuable to the end users who is actually buying the research, because it's not just like people are actually looking for information which is available in the internet or something like a deep research that they can provide. They're actually much looking for information much more like deeper insights, right? So I think that way our job is actually getting really interesting, is what I feel.
Yeah. Okay, fantastic. Manoj, thank you for taking the time to walk us through these fast-moving developments. Your insights really help to make sense of where we're heading. So thank you.
Thank you for the opportunity. Love talking to you and appreciate the opportunity. Thank you.
Thank you.